So today's our first lesson for COMP1006, Intro to Web Programming. We're only going to have one video for today because our first hour of class is kind of getting to know each other. In the video, you don't need to look at me. You basically will see my screen and hear my voice, which means I won't stray too far from here because my mic is not that good. It also means if you ask a question or answer a question, I'll often repeat what you said so that it gets captured in the video as best I can. Occasionally, the audio encoder on this isn't great. Sometimes the audio gets a bit fuzzy. I do the best I can with the tools I have. All right, so looking at our thread. All right, I'm not going to read over all this stuff. I'm maybe just going to touch on a couple of highlights, a couple of the important things that you guys found out. And again, this thread will be open. There will almost certainly be some questions in our first review quiz next week where the answers are in this list. Okay, and this list will also be available during your midterm. So I just want to point out the stuff that's really important. This is one of them. Okay. All our PHP code gets enclosed in these little PHP blocks. If we don't, it means two things. Number one, the code doesn't execute. Number two, the code will get printed to the screen as raw HTML. So we always want to make sure we have those opening and closing tags around our PHP code. So in a complete file, we're probably going to have, we'll be constantly going in and out, interchanging between PHP code that executes on a server and HTML. So a file might look something like this at the end of the day. Let's see if pull up a file from. Let's look at this file for a minute. So here was a completed file. So we have a block of server-side code at the top, and then just a bunch of standard HTML. And then in the middle, we have this drop-down list that we want to use PHP to go and get a list from the database and stick those items in drop-down list. So you can see we've got the opening PHP tag. And here it closes. That means the PHP ends, and now we're back into regular HTML. And then we've got some more PHP code, a whole bunch of logic here in case the user tries to do a search and maybe they get an error, etc. So we've got HTML and PHP code mixed together, but those little tags indicate the difference. This is PHP code and this is HTML. It's not the cleanest, but that's how PHP works. A lot of people mentioned that it's free and it's platform independent. That's one of the reasons it's so popular. There's no cost to use PHP and we can run it on anything. Here's one of the other important points. We'll talk about this a little bit. We may get to play around with this today. Your PHP code needs to be executed on an actual web server. It's not like HTML in this case. We can build an HTML file. We can just browse to it, open the file in our browser. It's going to load. If we do this with PHP, all of the code gets ignored. We can't just open a PHP file through the file system. It has to be served from a web server because the web server has a PHP interpreter that will read all the code in those blocks and execute it. So we've got two options for a web server. We can install a local server. That's what that Zamp server program is for. That's a local server that runs on your own machine. It's free. We also have the AWS web server, so that's Amazon's cloud server. So when you submit assignments or labs to me, you're going to have to put your code on the web server so I can run it live on the internet. Because without that web server interpreting the code, the PHP code doesn't do anything. Definitely, we're going to use it to work with the database, and that's why the things we do in this class, they're going to integrate well with the concepts you're learning in your relational database class. There's a reason we have them together in the same semester. This is also important. All of the PHP scripts are executed on the server. None of the PHP code ever gets sent to the browser. Users cannot see the PHP code, and this is important. We don't want them to see it. This is all our back-end logic. It might contain things like our username and password for our database. So that code will be in our files, but it is not served or sent to the web browser. So that code is private, held privately. And primarily it's used for creating interactive web pages. We'll come back to this and talk about this a bit more in a bit. Sure. That's a great question. There's a few ways we can do it. The first thing is if something is wrong, there's a good chance we're going to get an error message. We'll see a syntax error. None of our HTML and CSS is going to load. We're going to see that error message. That's very helpful as we're developing, right? When things break, we want to see those error messages so we know what's wrong, and it'll usually tell us what line number, and then we know to go to that page and fix it. Once our sites are in production, we don't generally want to show that to people, right? What should we show people instead if something goes wrong with our server-side code? If we don't want to show them the error messages. What happens on a website when something breaks? What do you usually see? Yeah, you'll see some kind of error page that will still have the site layout with the HTML and CSS, right? A friendly error page. So that's typically what we'll want to do, and that's, I think, after reading week, one of our first lessons is on error handling. So how do we check for errors, prevent the error message from showing to the users, show them a friendly error page, but then what can we do so we get notified? So one of the ways we do it is actually in this sample file I showed you. So here's all my code, and up at the top here above this block of code, there's this try command. So try to do all of this and catch any errors. So what's going to happen if an error is encountered with this code? Two things are going to happen. What will it do? Yep. Yep. Right, so this will catch any errors that happen. So the error message doesn't get displayed. I'm doing two things here. So what two things am I going to do if an error happens on this page? Yeah, it's going to send me an email with information about the error. And it's going to load our friendly error page that has our header and our footer and our CSS. So the user doesn't see the info, but I'm going to get an email saying, hey, this happened. So that's one way. Another way we could do it is we could create an error log either as a text file or in our database. We could write the error in there as a log. So we have some options. Yes, I do. In fact, when I did that website for Walmart, I set it up so that it would email me errors. And every night around 3 a.m., I would see all of the hacking attempts. So people would try all kinds of ways to hack into the site, but I had proper error handling that would catch the errors and it would email me. So I could see all of the things they tried putting into like the login form. Every morning I'd wake up to about 25 emails that were sent every day. So yes, you can't see it through the browser. We need some other mechanism to handle and keep track of those errors. When we're developing, we don't want the error handling. Just let it crash, see the error, go and fix it. But once we're in production, so we'll do this, we'll implement this in our PHP site. Yep, you could do that. Yep. Okay. This is an important one. Okay. So things that we name in PHP are case sensitive. Okay. So if we create something called first name, all in lowercase, and we then try to refer to it later with first name with a capital F, PHP considers those two things separate. Okay. So we should be mindful of how we name things in PHP. We should do things consistently because it is case sensitive. Cassio, you had a question. Can I ask you to ask that question again? Okay. So PHP is one of several. So So this is a fairly up-to-date list. Now, this is not specific to web. This is all software. And this is a kind of a current list, at least by one metric, of the most popular programming languages. Now, Java and C, we don't really use those in web. Those are primarily used on other platforms. Java for Android, for example, for desktop development, C for all kinds of things. Python's used for a bunch of different stuff. C++ has lots of different uses. Again, there's not really a C++ for web framework. So the ones that are used for web primarily are C#, JavaScript, so that's Node, as well as front end, and PHP. So PHP is probably still the world's most popular language for web, and that's largely because of this guy. Largely because of WordPress, which is the world's biggest content management system. Many, many sites use WordPress. WordPress runs on PHP. Right? So sites like even the college, so the public face of the college website is WordPress. And it's actually really easy to see. There's two really easy ways to know that this is WordPress and PHP. How could you find out when you go to any website what technology it actually uses? There's a quick and dirty way, and there's a more sophisticated way. Yeah, we could inspect. So if we go in here and look at the source, we can pretty much tell right away this is WordPress. How could you tell? I can tell on both line 11 and on line 21 really quickly that this is definitely WordPress, which means PHP. Right? Wherever you see WP content, that's WordPress. And wherever you see this, the Yoast plugin, that's also the world's most popular SEO plugin for WordPress. So you'll see these things in the header of any site that uses WordPress. So that's one way to tell. There's one other useful tool. I've actually put a link to it in Blackboard. I meant to put it up. It's now in useful links and resources. That's this. Web Technologies Inspection Tool. This is cool. You can put in any domain, and this tool will tell you all of the technologies that website is using. And sure enough, anything starts with WP is WordPress. So these are all the WordPress plugins. So we know it's WordPress. This is also handy, Jeffrey, coming back to your question of how do I find freelance sites? When you go to somebody's website that you decide really needs an upgrade, you can throw it into Built With and it'll tell you how it was put together. So the link for this is in here, this Web Technologies Inspection Tool. So WordPress is by far the world's most common content management system. So any site that uses WordPress is using PHP. So Cassio, to come back to your question, sorry, a bit of a side tangent. PHP is probably on its way out. I would say probably 5 years from now, we may not teach PHP anymore, but it's still the big player. It's not the best technology, but the reason we're using it is this is our intro course. PHP is quite simple to learn. It's flexible. It's not complicated. Personally, if I was going to build a website for a client from scratch and they said, use any tool you like, I probably wouldn't use PHP. But it's a great place to learn. There's also a really good chance that many of you are going to wind up working in places where they do things in WordPress, where you're taking WordPress, you're building plugins, you're customizing it. So you need to know PHP how to do that. So we use, I'll get to your question one sec. We use PHP kind of as a starting language to introduce the idea of web programming concepts. And then we'll use Node.js next January, and we'll use ASP.NET next fall. They're a little more advanced. And those tools, they automate a lot of the repetitive tasks for us that with PHP, we're going to do manually. We're going to do them manually, it's more work, but we're going to understand better what we're doing. So we're going to kind of do the simple version of things with PHP first in this course, and then we'll use ASP.NET and Node later, which will be more sophisticated ways of doing things that are also higher performance, because those languages are compiled They're more secure and they're faster, but they're more complicated to use. So probably I wouldn't recommend doing Node for an intro course. It's going to be too difficult and too confusing. PHP is simple. We can get stuff to work pretty easily in PHP. Did that answer your question? Yes. Many places have moved to Node. So Node, where everything is JavaScript, both the front end and the back end is JavaScript. And we're going to learn that. We'll do that next January. That's probably going to be the replacement because A, it's free. B, JavaScript is universal. So it has all the same characteristics of PHP, but Node is much, much faster. And we'll look at that in next January. But I think it's already happening that we're seeing more and more Node and less PHP. The thing that will kill PHP is when WordPress is no longer the dominant content management system. And there's probably two reasons that will eventually happen. One, somebody will invent a content management system and market it that's just much better. Or two, WordPress will develop so many security vulnerabilities that people will be afraid to use it. And then they'll look for an alternative. So Scott and I have already had the conversation. Should we still be teaching PHP? But as long as WordPress is still so dominant, I think it does make sense to use it at least for an intro course. Some of the other colleges, they only do PHP still. They're not even using ASP.NET or Node at all. Whereas we're trying to give you guys a bit of a flavor of all of them. You could use PHP for anything. Like, Facebook's pretty complicated. It's PHP. Probably if they were going to build it over again today, they'd probably use Node, I would imagine. Okay. So you guys have mentioned most of the important stuff. So I'll leave this up here so we can see our syntax here. There's one other important feature about PHP I'm just going to add to our list. And that is PHP is a loosely typed language. What the heck does that mean? This is probably more of a question for the programmers in the room. So we say programming languages can be strongly typed, they can be loosely typed, they can be untyped. What does that mean? And why is that kind of important? No, it has to, it's related to how we use variables. Right. So in a language like, so if you're in computer programmer, you took Java for programming fundamentals. If you're in web, who is your teacher for programming fundamentals? Sam? Yep. Okay, you had Radhika, some of you had Sam. So what language did you use with Radhika? Java? Or C#. So both Java and C# are strongly typed languages. If I'm going to create a variable called birth date, that variable has to be of type date, and it can only hold dates. Right? I can't create a birth date variable and give it a value of ABC. The Java compiler or the .NET compiler would throw an error and say, the value of ABC is a string. This variable called birth date holds a date. You can't do this. So we get more errors, but that's good because it doesn't allow us to put the wrong kind of data in the wrong kind of container. PHP isn't like this. PHP is loosely typed. So if I create a variable called birth date, I could give it a value of 1, 2, 3. I could give it a value of ABC. I could give it a value of January 1st, 1980. I could give it any, or I could change the value from a string to a number to a date to a Boolean. PHP allows us to do this. This is good because it's flexible and throws fewer errors, but it's bad because it allows us to do things we shouldn't do. Right? If we ask somebody to put in a birth date, we shouldn't allow them to save a value of ABC. PHP says, no problem. Birth date is just kind of this empty container. You can put anything you want in it. You can change what's in there. So this has implications for how we're programming with PHP. We have to be mindful of this because in Java or in C#, your development environment, it caught that stuff if you use the wrong data type. PHP doesn't care. It'll let you make those mistakes and it won't tell you you've done something wrong. Okay, so it's flexible, but it's more error prone and harder to fix when those errors happen. Yep. Yeah, I would suggest it's not great for security either, right? Because the language itself doesn't force certain data to be of a certain type. So there's more work for us on the programming end. If we're going to ask somebody to give us a birth date, we have to in code make sure the value they gave us is a date and handle it if they give us a string, for example. Java or C#, it's going to do that for us. So yeah, there's a little more manual work with a loosely typed language. Okay, so that's different than what you're used to working with. And you have to be aware of this with PHP. Okay. So how does this work with all the other stuff that we've been doing? So PHP, it can't do everything on its own. And what we're building in this class, we're basically going to be using 4 different technologies together in order to build a working web application. So PHP, it basically is the hub between all these other tools. On the front end, we have things you've already learned last semester, your HTML and CSS, right? That's what gets sent to the browser. It's the content and the presentation. PHP doesn't handle that stuff. That's not its job. Most of the information on the sites we're working with, and we'll talk more about this, most of this stuff lives in our database. So in this case, we're going to use MySQL. You're going to use MySQL in your relational database course. Later on in our other courses, we're going to use different types of databases. When we do ASP.NET, we'll use a Microsoft SQL Server database. When we do Node, we'll use a MongoDB, which is a NoSQL database. They're kind of neat. But PHP sits in the middle, and it allows all the things to talk together. So how, when I pull up a friend's Facebook profile, all of that information has to come from somewhere. When you click on someone's profile, where in this diagram does all that information live? Where does it come from? Yeah, it's all somewhere in Facebook's database. So PHP handles all the logic of what profile am I looking at, goes and talks to the database, makes a request for that information, and then translates it all to HTML and CSS so that it gets rendered on your phone, your tablet, whatever device you're using. Okay, so PHP is kind of the engine and the logic that runs the whole thing. PHP doesn't do the presentation and it doesn't store the data. It's like the messenger. So the thing is, the good news for you guys is that all of the web applications that everybody uses, they all work the same way. All the fundamentals we're doing in this class, it's all about, Ivan, coming back to your new favorite acronym CRUD. That's all every web application you ever used does. It's just a CRUD application running over HTTP in a browser. So once we understand the mechanics of how this works, we could build any kind of web application, big or small, for anybody. Using PHP, using Node, using anything else. They all work the same way. The really good news is for most people out there, this seems like some sort of magic trick, right? How can I trade stocks on my phone? How can I connect with people all around the world? How can I do almost anything I could possibly want to do in my browser? It's all create, read, update, and delete with the database in the back. That's it. There's nothing else to web program. So they'll pay us to do these things because we're the magicians. So everything here, every web application, every site you visit every day, at the end of the day, it's just ones and zeros. And we're using a language like PHP to interact. Okay. So let's think about this for a minute. We said, so what kinds of, I mean, Facebook's actually a really simple web application if you think about it. It's actually not that complicated. What kinds of things, if we had access, if we had the username and password and the server address and, you know, firewall access to Facebook's database, if we looked in their database, we'd see different kind of tables, different collections or containers in there. What different containers of information would you expect to see in the Facebook database? What kind of information's in there? Okay, profiles. What else would be in there? Yeah, a list of the likes. Yeah, a list of friends, right? So we have profiles, but then those profiles are connected. What else would be in there besides profiles and likes? Yep, pictures. Yep, the old accounts. Yep, keeps track of our locations, right? So it can target ads to us if you keep your mobile device GPS on. What else is in that database? Yep, pages and groups. How does Facebook make their money? Right? There's going to be a list of all the ads in the database. And then what's the primary content of Facebook? When you first log in, what do you see? What does it show you? Yeah, the feed, so all of the posts. Right? That's basically the entire Facebook application. We pretty much named everything that it does. So here was my list. You guys pretty much named them all. So all the Facebook front end are a series of PHP pages that allow users to create, read, update, and delete from these things. There's nothing else there. It doesn't do anything else. And there's some authentication. So you can identify yourself and it controls what you have access to. What about here? What would be in Amazon's database? We thought of the list of tables or containers in their database. Sorry? Yep, so the products, that's probably the primary table. Yep. Customers, prices, reviews, yep, transactions. That's the one Amazon, we're most interested in the products. Amazon's most interested in the transactions, right? That's why they spent the billions to build it, because they want people to create data in the transactions table and give them money. So that's what's here, right? As a customer, we're primarily reading the data, right? Show me a list of products. Show me information about this product, the product info, the photos, the reviews. Allow me to create a transaction where I make an order and I give you money. Right? That's all Amazon is. It's an interface where we read product data and we create order data. One more. So this is usually the first website I pull up each day. What would a newspaper's database look like? What would be in there? Yep, that's probably the primary table. If it didn't have articles, I'm probably not going to go there. Yep, could be based on tracking location. Dates, yep, the author. So there's a particular columnist I like to read. I should be able to click on that person and see all of their articles only. Yep, list of subscribers. Yeah, for sure, right? The article, I'm interested in the sports, so things are categorized, right? The nav bar right across the top. Which is loading slowly. So yeah, there's our categories, right? Sections. Each article is linked to a category. We've also got ads, photo and video. That's most of what's here. I pull up my list. Also comments, I think is but the only other thing we didn't mention, right? We can read a story and they allow us to comment. If we dare engage with the internet trolls, this is part of the theoretical benefit of reading the newspaper digitally as opposed to getting the paper copy, right? We can read the paper copy, but we have no way to necessarily interact with other people who've read the same things we're interested in reading. So that's why putting it online. But again, almost all we're doing, probably 90% of what we're doing on the Globe and Mail site is we're just reading information. Show me this category, show me this article. And occasionally we might want to create data. Create an account, add a comment, or update or delete. But most of what we're doing is reading data. So these things all happen They all work the same way. I actually like to compare it a little bit like going to a pub. Right? You think about the process of going out with your friends for drinks, right? Now, it would be great if you could walk into the pub and everybody could just walk behind the bar and help themselves to whatever they want. Doesn't really work that way. So going on Facebook and pulling up your friend's profile, pulling up your news feed, going on the Globe and Mail, reading an article, it's kind of the same thing. Okay. So in each case, we have a number of different parts. They've got different jobs and they work together. So I'll run with this analogy for a while. So in the bar on your left, that's the list of what they offer. Right? This is what's available for people to choose from. Kind of like we go on Facebook and we can see different links. We can choose what we want, right? Do I want my news feed? Do I want my friend's profile? Am I interested in this group? Am I interested in this video? So there's this whole catalog of stuff I can pick from that I want to see. But in the bar, I can't go behind the bar and start pouring myself pints as much as I might like, just like Facebook doesn't make their database available to us. Here you go. Here's our data. You sort through it and pull out whatever you want. There's a process. So in the bar, they've got containers with everything. In our database, we've got tables. And that's what we're teaching in your relational database class, right? How do we create a database, organize it, structure it, and pull stuff out that people want, right? How do we write the code? When I click on Jeffrey's friend list, that it shows me all of his friends. So in the pub, you have somebody that comes and asks you, what is it you want? Here, the way this works on the web is we can make a request to a web server. Some website / some page name, right? Facebook.com/Georgian College. We're requesting information about the Georgian College profile from the Facebook database. So our server might scribble down the instructions. In a web context, the instructions, and this is what you're learning in your database class, SQL is the language we use to make requests or set instructions to a database. So that's why we're teaching you SQL. We're going to use some SQL in this class, but you're going to do more advanced SQL in your database class. So when someone wants something from the database, you know how to ask for it. Or someone wants to save new information, you know what's the command that I can add this information to my database so it's stored permanently. Okay. So then our server comes back, they take that instructions, the server comes back with the drinks, right? And they start handing them out. Here's what you ordered, here's what you ordered, here's what you ordered. Our PHP code or ASP.NET or Node does the same thing, right? I click on somebody's photo gallery, it's going to go and fetch and display all the images and give me back what I've asked for. So it's kind of a similar process. So in the bar, you have all of these pieces, right? You have some physical pieces, and then you have some people working in this environment to be able to ultimately fulfill the whole point of the place. And then here are all the technologies we need. A database to store the information. Our user needs some kind of web browser to see the information. And then we use these technologies, largely HTML, server-side code, and SQL, so that our application can interact with the data. So users can create data, they can read it, they can change it or delete it, whatever it is we want them to do. Most of the time, we're reading data. We do more reading than anything else. Okay. One last thing I like to say in this is, but this time, this is for the designers in the room, the people who, I'm a creative type. Yeah, it's probably good I know a little bit about this stuff, but really I want to make amazing looking things. That's fine. Good for you. There'll be tons of jobs and you can do really interesting work. 2 reasons why this class and the other ones we're going to have together are important. Number one, many of you are going to find you're actually much better at this than you think you're going to be. It always happens. That there's people in this class who think I just need to get through it. And once they start working with it, they realize, hey, I'm actually good at this. I understand it. That's number one. Number two, if you're good at this and you're a good designer, you are what we call in the industry a unicorn. Because there are many people like me who can program, can't design, many designers who can't program. The people who can do both, who can make something work well and make it look great, those people have create awesome opportunities for themselves, and they're hugely in demand. The third thing is, even if you're not the person who's going to be building this and putting this stuff together, if you're only doing design and front-end work, your designs and your work is going to have to work with people who are building this stuff. So the more you understand about it, the better. Not necessarily. No, depends on where they work. The larger the employer, the more likely they are to have people in specialized roles. But particularly in smaller companies, people who have a broad skill set are more valuable. I remember having a conversation with a student who graduated a few years ago, and she was a very talented designer. She did okay in this class. And then I saw her, she came back in September at the end of her co-op, and she said, guess what I did for my whole co-op? All I did was PHP. They hired me as a designer, and then we had a whole bunch of PHP work to do, and it turns out I knew more about it than anybody else in the company. Everybody else only knew design. So she said, I wound up having to do nothing but PHP, and I'm now much more confident at it, and I did much better at it than I ever thought I would. So, we're trying to train you that to be able to do front end, back end, design only, or everything, really wherever your interests lie. So my suggestion is, if you're really interested in design and that's what you want to do, great. By all means, we have got lots of really successful students who've had great careers and that's all they're doing. But the more you know about the other stuff, the more it's going to help you and the more options you're going to have. There's also quite simply more developer jobs than designers, right? To build a big web application, you might only need one designer, but you may need 4 or 5 developers. You're not going to need 4 or 5 designers and 1 developer to build things. So that's just something to keep in mind. Okay, we have about 20 minutes left. We're going to try building just a couple really simple PHP pages. Now I'm going to show you how, I'm going to run it on my local server. So I'm going to show you how to start the local server. Then I will also go through the process of how I put this up on the web server. We'll go over this again over the next few weeks. So I have the Zamp server installed. So to start my server, I'll just search for and open up my Zamp control panel. And it'll look like this. So there's a whole bunch of services here. Excuse me. I only need this one. I only need the Apache server. That's the web server. So notice beside Apache, I have a start button. That's because my server is stopped. So if I press start, it shows me my server is running. And it shows me 2 ports. By default, your local server will run on port 80. I have a different server running on port 80, so I had to change my Apache server to use port 800 instead. So if you install Zamp, the installer creates, if you're on Windows, in the C drive, it creates a Zamp folder with a whole pile of stuff here. And in here, there's a subfolder called htdocs. This is where I have to put all of my PHP pages in order for the web server to execute the code. So I'm going to create a very simple PHP file here, and then we'll try and load it in the browser. To check that my server is running, I'm going to go to, if you have Zamp running, you should be able to just go to localhost. I have to use localhost :800 because, as I said, my default port 80 is being used by a different server. So if your server is running, you get this Zamp homepage. If you don't get this for today, don't panic. Make sure you have Zamp installed for next week. So I'm going to create a really simple PHP page, and then I want to load it in the browser. So I'm going to open up PHP Storm. You can use Visual Studio Code. You can use Notepad, brackets, Atom, any kind of text editor you like. So I'm just going to click on Open, and I'm going to browse to my C Zamp htdocs folder. So I'm just opening up my root folder because I want to create a couple of PHP files in here. So I'm going to create a new PHP file. So I just right-clicked on my directory. I chose New PHP file. And it asked me to give the file a name, and it automatically will assign a PHP extension because I chose New PHP file. Or I could just choose New File and make sure I give it the extension .php. The extension is really important. Every file we make in this class will have a .php extension. I'll show you why in a minute. I'll just call this one info. And my code editor will kind of give me a default HTML5 template here with a simple header and footer. We're going to write the world's simplest PHP file. I'm going to open a set of PHP tags. And when I hit enter, this is one of the things I like about WebStorm. I added the tag on line 9. WebStorm automatically closes the tag for me on line 11. I'm going to put in a comment here explaining what we're doing. We're going to use the built-in PHP info function to get server to client info. So we're going to write one really simple line of code. We're calling a method that comes with the PHP library. We're not creating our own method. This is a built-in method you get when we install PHP. And like in Java or C#, we should terminate our commands with a semicolon. So I'll save the file. And now I want to go to my browser and try and load it. So if I replace this, I try and load info.php, that one little function gives us a whole lot of info about our server and our environment. A lot of this stuff we don't care about, but it has some useful things. Tells us what kind of web server we have. We have an Apache server. It recognizes my operating system as Windows 10. Gives me the port. And says things like the file path. A lot of the stuff we don't care about. So that one little method gives us a whole bunch of stuff. It'll tell us if there's cookie information. There are a couple of other useful things in here. So it has these sorts of variables. Like somewhere in here, it should show my IP address. It's in here somewhere, I'm not sure where. So this file has to be served from my web server. If I just try and open it from the file system, I click File and Open File, I'll browse to it this way. If I open it this way through the file system, notice I don't get any of that info. Because I'm simply opening the file, I'm not serving it from the web server when I do this. So this is why we need to have a web server, because that PHP code gets ignored unless it's served over HTTP from a web server. Okay, I'm going to take all of this code and copy it. We'll make a couple of other simple files. This time I'm going to make an HTML file. And I'll call this info. But this time I'm going to use an HTML extension instead of a PHP extension. I'm going to just copy and paste all my code. So the two files are identical. I just have a different extension. So the first one is .php. The second one is .html. What do you suppose will happen if I try and load this file in my browser? There's several possibilities. What might happen? To put everything as text? Okay, so if it ignores the PHP, what should we see in the browser? Yeah, just a blank page. Or it could, yeah, is it just going to write this stuff as HTML to the screen? All of those are possibilities. Let's see what happens. So if I go to this one with info.html, so that script just gets ignored. If there's without a PHP extension, the web server it ignores any code inside those PHP braces. Doesn't care about it. What about? So here's the other trick. Let's do this. So here's the PHP version. We have all this HTML. If we look at the source of the page, and Emily, this sort of comes to a question you asked earlier about inspecting the code, right? If we view the source, here's my working PHP that has all this HTML. If I actually do a search for my PHP info function, so the code we actually wrote, notice it's not here. That code doesn't get sent to the browser. It stays on the server. That's why it's called server-side script, right? We can't see or debug any of the PHP code. But on this version, without the PHP extension, yeah, we don't see it in the browser, but our code, rather than staying on the server, we've now published our server-side code to the internet where a user could see it in the source. So this is why we're never going to use .html extensions in this class, because every file we build is going to have some PHP code in it, or potentially could have PHP code in it. So we never want this code being sent to the browser for users to be able to see or change. Okay, we're going to build one other simple file and we will call it a day. This won't take us long. Just to experiment a little bit with this so that we talked about this in theory, but we'll actually try this out, how this works. We'll make a new PHP file. I'll call it variables. Doesn't really matter what you call yours. So we're going to play around with the loosely typed nature of PHP. Just a minute. Do a really simple example and we'll call it a day. I'm going to put on a block of PHP code. And I'm going to create two variables. In PHP, every variable has to start with a certain character. Did anybody happen to notice this when you were doing your little 10 minutes of research? You got it. So whenever we see all variables need to be prefixed with $. So we'll create X and we'll create Y. Well, actually, I guess we'll say 3. So now we want Z. Now notice we've never actually said X and Y are numbers. If this was C# or Java, we'd have to declare that X and Y were integers or decimals or some kind of numeric type in order to add them together. In PHP, all we do is create the variable and we give it a value. And then if we want to display the value of Z, PHP doesn't have a print command. It does, but it's not used for something else, which is annoying. The PHP command to write something to the page is actually echo. So we're going to add X and Y together, store the result as Z, and print Z to the browser. So we'll save that. And we'll try it out quickly. So it seems to work. It figures out those are two numbers. Hey, we can do math. That's going to work. But it doesn't force us to say these are numbers. What if we tried this? Let's see if we do this. What are they going to do? And now we've got two dates. I don't know what's going to happen. Okay. So it's not that there's no notion of data types, but it's loose. It allows me to assign date values here, but once it gets to this line which says, now this person's trying to do math with these two values, it then kind of tries to infer what type of data is it. And are we saying, no, if you want to add them together, those should be numbers. Dates won't work. Or if we do this. So same thing, it's not going to be able to add them together as strings. PHP also, this is the last thing we'll do. PHP treats plus signs really strangely. If this was C# or this was Java, this code would actually work, wouldn't it? What would you expect it to display if this was Java or C#? Yeah, it would concatenate and say A, B, C, D, E, F. Treat them as strings and append them together. In PHP, this only is a mathematical operator, the plus sign. It doesn't actually work for appending or concatenating strings together. It has a really stupid, confusing operator instead of a plus sign. Anybody know what we would need to replace this plus sign with? in order to append these. We can try an ampersand. Let's see. Not quite. Didn't get an error, but we didn't get the result we wanted. Has a really strange concatenate operator for strings. In PHP, it's a dot, which is bizarre because dot is usually a separator. This is one thing and this is another thing, is how we understand what a dot is. In PHP, that's actually the concatenate operator, which is really bizarre. So we'll use this a lot, right? We're going to have first name and then a space and then a last name. We're going to need to use this funky dot operator, which is strange. So we didn't do too much with these files. I will still upload them to GitHub so that you have reference to them. If you don't have things installed yet on your computer, can you please do it before class next week? Because we want to be able to build pages and run them. So I know we didn't get a chance to run them on AWS today. That's okay. That will give you your VPN connection set up. If you need help with it, book an office hours appointment or email our CS tech at Georgian College and they can help you with it, because we'll need the VPN to be able to run things on AWS. So we'll do that next week. We'll start class next week with a really brief multiple choice quiz, 5 questions on basically the stuff you guys put in the forum today. Okay? No, it doesn't have to. It can go anywhere.